So we use quotient rule when we're trying to find the derivative of a function that can be thought of as created from a quotient of two other functions. And quotient rule is a little more complicated than product rule for memorizing. The little trick that I told you guys in class is if you think of the given function, the numerator as being high and the denominator as being low, then dy over dx, you can use a little rhyme to help you remember, would be low d high minus high d low all over low low. Low d high minus high d low all over low low. Okay, so that says the same thing as what quotient rule says. So it's basically the denominator then times the derivative of the numerator, right? So d high is the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so whatever you want to use to help you remember it, but you need to remember it. All right, so quotient rule. So before we wouldn't have known how to find the derivative of this function. So we now have quotient rule in our toolbox, which we can use. So let's find y prime. So we'll bring up the denominator and then times the derivative of the numerator, which is just 2, minus the numerator, and then times the derivative of the denominator, which is just 2x, all over the denominator squared. So now let's clean up the numerator a little bit. Let's distribute that 2 in so that we have 2x squared, excuse me, minus 8, and then minus 4x squared. And combining like terms, we'll have negative 2x squared minus 8. And I'm just going to leave there. You could always, if you wanted to factor, you could factor a 2 out of the numerator, you could factor a negative 2 out, you could pull the negative out front. Be careful where that negative is placed. So if we think about factoring out like a negative 1, then the numerator would be 2x squared plus 8. Okay. And then we're just going to practice our quotient rule here. So this is a function that you could rewrite in order to just use power rule to find the derivative of. It'll be your preference really on the test. I'm not going to specify which rules you use. It's going to be up to you to determine, because often there's different approaches and different combinations of rules that you could use. So let's practice with quotient rule here, finding f prime of x. So it'll be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. All right, so let's clean up the numerator, distribute the x squared in. So we'll have 2x cubed plus 2x squared. And then when I distribute the 2x, that'll be minus 2x cubed minus 4x squared plus 2x all over x to the 4th. And then I have some like terms I can combine. Well, those guys will cancel. And then 2x squared minus 4x squared can combine. So we'll get minus 2x squared plus 2x over x to the fourth. And notice that we have a common factor of x in the numerator. We'll actually have 2x. So we could, why don't we factor out a negative 2x actually? Now this would all depend, like you could be done, but it depends on what you're trying to match your answer to. So if we factor out a negative 2x in the numerator, then we'll have x minus 1. So negative 2x times x minus 1 over x to the fourth. Where now, this x can cancel with one of the x's in the denominator. I'll pull the negative out front. Just think it looks nicer. So 2 times the quantity x minus 1 over x cubed. Okay, so we'll do one more example with quotient rule. So before I apply quotient rule to find the derivative here, I'm going to rewrite the denominator as x to the 1/2 minus 1. So dy over dx, can use y prime or dy over dx, will be the denominator. Oops, didn't mean to put that extra parentheses. All right, so the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And then all over the denominator squared. Okay, I'm going to distribute the 3. So that'll give me 3x to the 1/2 minus 3. And then distributing 1/2x to the negative 1/2. I'll have minus 3/2 x to the 1/2. Right, x times x to the negative 1/2 is just x to the 1/2. And then minus 1/2 x to the negative 1/2. Okay, okay, so we have a couple, we have like terms to combine. So 3 minus 3/2 is 3/2. Minus 3. And then I'm going to rewrite negative 1/2 x to the negative 1/2 as 1 over 2 times x to the 1/2. So as a complex fraction. So now if we want to get rid of the complex fractions, let's multiply by a version of 1 that would get rid of the complex fraction. So the least common multiple of the denominators of the complex fractions, think back to limits, right? LCM over LCM, would be 2x to the 1/2 over itself. Okay, so remember the division bar is a grouping symbol, so then we distribute. And we'll have 3x minus 6x to the 1/2, and then just minus 1 over 2x to the 1/2 times x to the 1/2 minus 1 squared. Okay, so we've gotten rid of the complex fractions. There's no negative exponents, so I'm going to leave there.